Hello and welcome. In this video, we will take a closer look at different aspects of working with regions in Halcon. For an introductory tutorial on the different variable types in Halcon, click here. In this image, we want to count the number of white beans and chickpeas. Typically, the first step in working with regions is segmentation. This means that you want to separate the background from the object you want to find. There are various operators for segmentation available in Halcon. One of the most commonly used is threshold. It can be easily configured using the gray histogram assistant. Here you can see the gray value distribution of the image. To set up the thresholds correctly, it is useful to enable the visual output. Then, you can move these vertical bars to adjust the upper and lower threshold values. These low gray values constitute the background, which we want to exclude. When you are satisfied with the result, you can click this button to insert the code into your program. Now you can see that the operator has been inserted with the thresholds we configured. The result is this region. Next, we want to compute the connected components to try and count the beans and peas. For this, we use the operator connection. We can see that it works fairly well when the objects don't lie directly next to each other. However, these beans and peas are not separated correctly because they are touching each other. So for now, this operator is useless. Let's delete it. We need to separate the beans and peas that touch each other. One common way to do this is to use morphology. Let's take a look at this example program to understand the basics. Morphology is a technique used for the analysis and processing of geometrical structures. Here, we draw the input region we want to process and the structuring element. Now, 4 important morphology operators are visualized. With dilation, we can enlarge and smooth regions. In contrast, erosion reduces the area of a region. Using closing, we can fill holes and close gaps between neighboring regions, while the original regions remain mostly the same. Lastly, with opening, we can eliminate small structures and protrusions. Let's apply this new knowledge to our example. First, we want to get rid of all the smaller areas. Using opening circle with the default radius eliminates a lot of them. Then we use a standard operator chain to separate neighboring regions. First, erosion circle shrinks the region. Here you need to find a value for radius that separates the touching regions. 11.5 is not large enough. However, a value that's too large will make the smaller regions disappear. Here, a value of 21.5 is practical. Now that the regions are no longer touching, we can use connection to separate the beans and peas correctly. Lastly, to restore the original shape of the regions, we use dilation circle with the same radius as in erosion circle. Now we want to separate the white beans from the chickpeas. For this, we want to use the different features of the regions. You can select regions with Select Shape. In the Halcon documentation, in the chapter reference of Regions Features, a lot of different features are visualized. Here, we can look for a feature that could be used to separate the peas from the beans. For example, circularity might be a good feature, since the peas resemble circles much more than the beans. You can configure the Select Shape operator using the feature histogram. Again, enable the output. Additionally, it can be helpful to change the visualization color. Let's choose white. Sometimes, for easier visualization when working with small regions, it is a good idea to use margin instead of fill, with a high line width. Then we can choose from all the features available in Halcon. As mentioned before, we want to use the feature Circularity. You can see that the two groups are easily distinguishable. Adjusting the thresholds allows us to select only one group. When we're satisfied with the result, we insert the code. We can see that the Select Shape operator has been inserted with the chosen feature and thresholds. We can rename the parameter Selected Regions to Peas to make clear that this is the result. Next, we want a region that encloses only the beans. When working with regions, set operations are available, like difference. We can take the region dilation, and subtract the peas. The resulting regions represent the beans. Lastly, as part of this program, I prepared a local procedure to visualize the peas and beans. We can see that the peas and beans have been segmented and separated successfully. This concludes our video on working with regions. You should now be able to use the gray value and feature histogram and apply morphology to regions. You can download this example program here. It includes a small exercise you can try and solve. Check out our YouTube channel for more tutorials and information about our products. Thank you for watching.